14th question says sand is pouring from a pipe at the rate of 12 centimeter cube per second. Okay, from a pipe. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. Okay, radius of the base is important, height is important, there's some relation between them. How fast is the height of the sand cone increasing when the height is 4 centimeter? We're interested in these things. Let's talk about the diagram first. So on the ground, you'll be having a conical sand pile. This is the conical. This looks like some kind of cone. This is the ground. Okay, this is the ground. And the cone from the side angle will look like this. You can draw a circular over here. Yes, you can draw a circular over here, but this is the radius of the cone. I can mark the radius in this manner. And this here will be the height of the cone. This is the height of the cone. Sand is pouring over here. Sand is pouring from a pipe. Right? Sand is pouring and we are getting a cone formation. There's some relation given, right? This is a shape and then there's some data given. Let's note the data. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. This is basically the volume of the cone will be increasing by that rate, right? Sand is forming the cone, so volume of the cone is increasing at that rate. dV upon dt is given to be 12 centimeter cube per second. It also says centimeter cube. This is volume, right? What is the volume of this cube, by the way? Do you remember the volume? Yes. This is 1/3 pi r square h. This is the formula for volume. 1/3 pi r square h. Okay. The falling sand forms a cone on the ground in such a way, height of the cone is always 1/6 of the radius. Height is 1/6 of the radius. This is also given, right? That's another relation given over here. Okay, what else? How fast is the height of the sand cone increasing? dH over dt is being asked. Okay, when the height is 4 centimeter. This is being asked. Height is 4 centimeter. When height is 4 centimeter, what will be the radius? Radius will be 6h, which gives me at this particular point, radius will be 24 centimeter. This is what you have, right? Next. We are dealing with the volume, right? It is given this, and we are asked this with the help of maybe R and H, the values of R and H. So let's use this V equals 1/3 pi r square h. Do you observe that dH by dt is what we are supposed to find? There should not be any R remaining in this formula before you differentiate. So let's eliminate R with the help of this result. R equals 6h, right? So this gives me V equals 1/3 pi R square becomes 6h square times h. And what is this? 1/3 pi is okay. This is 36. H square times h is h power 3. This becomes 12 pi h power 3. This becomes 12 pi h power 3. 36 upon 3 is 12. There is a pi and there is h power 3. This is V. Okay. Next, let us differentiate this volume with respect to T. Volume with respect to T. Therefore, dV by dt is equal to, this gives me dV by dt is equal to 12 pi times 3h square dH by dt. Oh, we don't need this one actually. We only need h. Okay. And we can find dH by dt very easily. Therefore, let's substitute the values. This is 12. Consistency of units has to be meted out. This is length is in centimeter, those are the only units given. Time is in seconds. So 12 will be equal to 12 pi times 3h square, which is 4 square times dH by dt. This 12 goes with this 12. This implies dH upon dt is equal to 1 upon pi will go over there. 3 times, this is 16. 16 times 3 is 48. This becomes 48 pi. Is that all? Yes. This is 1 upon 48 pi. And h is in centimeter. This is in seconds. So the answer will be centimeter per second. This is the final answer for this question over here.